Thank you.
Thank you, everyone. All right, I'm gonna operate. So, as our intro stated, I'm functioning as a technical product owner for Toyota, and most recently have moved into a role looking at AI strategy and delivery across all of our projects. One of the things that we're gonna highlight today is how we are moving our projects that we started, I'll call it like the first phase of generative AI, and utilizing some of the second phase technology and upgrading them into what we call our agentic future with a enterprise SaaS strategy outlook. Ravi has been instrumental in leading this, and some of the conversations, some of what we're gonna look at today were concepts that we thought of about a year and a half ago that the business wasn't super ready to adopt, and now we've finally been able to deploy most of them and start working them into the existing projects.
Cool, yeah, thanks, Stephen. So my name is Ravi. I'm the technical architect for Toyota, for Generative AI team. So I've been working with Toyota for the last 4 years now, and I'm in the space of AI from last 13 years. So it's a fun ride. I'm really loving it. I think we're gonna show some of the cool stuff that we've done at Toyota and how we are applying that to cars, which you guys drive every single day. So yeah, with that.
So we'll give a brief overview of kind of how our department operates and what are the key elements that allow us to move as fast as we do. So when Toyota came up with the idea of having an enterprise artificial intelligence team, somewhat differently than most Fortune 500s, where they created like a center of excellence that was a little bit more focused on business and like business enablement, ours was very engineering heavy. So we started with 5 or 6 engineers, all of us being practitioners and having built out practical applications in specifically generative AI applications before we formed the team. So Ravi had been working on a couple of implementing some of the hackathon projects, and then I was at Toyota Connected, which works on our multimedia system, and we built a couple of fine-tuned models for Stable Diffusion 1 that did image generation for the vehicles. And that was kind of like our first experimentation between utilizing those systems for, I guess, like some of the first initial outputs that you could then deploy to the public, before working on things like efficiency. So we did a couple of projects where like we wanted to shorten owner's manuals by selecting important information that needed to stay and then being able to like decide which pages didn't need to be printed across a body of manuals. You would not be surprised, it was about $22 million a year in savings on printing paper by figuring out which pages you don't need to use. And so those are the kind of projects that were, once we had like put some of those out there, our leadership realized, hey, if we put all this together, we can actually figure out how to accelerate and stay on top of the edge of the curve and also utilize these in production. Because one of the things about research is that typically it takes forever in Toyota for it to get to production, and we were turning these things out like 3 or 4 months. Everyone who's been in this space understands that like every 3 months everything changes, and so if you have to go through like a 9-month approval process for a project, it's basically still and dead. So this was the structure we came up with to basically figure out how to help the rest of the company move at that speed. So we start on exploration with business units and sometimes individual engineers going through experimentation, educating all of the stakeholders about why the project's important and like how we want to deploy it. And then we also have full stack DevOps and infrastructure to be able to enable those, and then engaging with the users to get feedback and iterate very quickly. We also work with our governance teams to ensure that we're following best practices for security and also compliance, so that we don't end up in situations like we've seen with some early adopters of AI where you get sued for misinformation or like selling cars for $1, you know, having bots that give, you know, bad airplane information. These are all the things that our leadership comes to us and legal comes to us and says, hey, we need to stop this. And then we walk them through, these are our guardrails, here's how we customize them for Toyota, and we're using Toyota data and compliance and baking them into every system. And a lot of what Ravi's gonna show later for the architecture is how we make that not just seamless through the projects, but dynamic, so that we don't have to keep building every single time we need to update things like compliance guidelines or privacy, or just new regulations. So one of the things that we wanted to kind of lead off with is this idea of an interoperability framework. So everybody's heard agentic for everything, either from vendors or on LinkedIn. And while that is a concept that I think everyone knows how to speak to, not a lot of people have envision what that looks like. So we probably have every SaaS provider that's available to Fortune 50s and Fortune 500s in our environment, and all of them have some kind of agentic framework. So what we're trying to standardize on is a couple of key frameworks that every business unit uses, and then utilizing the software that Ravi's going to show, architecture that then helps make those two communicate between each other so that you can build agents for specific business units with their unique workflows, but not be pigeonholed so the data can't flow between the two. And by doing that, we'll be able to actually leapfrog some of the digital transformation tech debt and hurdles that popped up before all the generative AI stuff showed up, which basically was kind of like a vestige of RPA. Because I think what's dawning on a lot of people is that RPA had a lot of promise, but because everything was so strict and rigid, it wasn't very dynamic. You had to keep rebuilding your workflows every single time something changed. And in Toyota, data changes all the time. And so we were like, okay, we all know underneath most agentic workflows is the same code and mostly the same methodology. So we don't actually have to work so hard for the interoperability piece. It's more of unblocking that interoperability as opposed to then needing to then build, scale, and then connect. So we're looking at this almost like as data layer is standard ML, standard AI, like machine models that become tools, and then business rules are the workflows that the business is putting together. We have the orchestration layer through our agentic frameworks, and then we turn that into bots that are the agents that go into the UIs that they're already used to using. These are some of the projects that we are in the process of upgrading and turning into some of those bots that are going to go into this new multi-use platform. So Battery Brain is a project that helps reduce time to knowledge for battery yields in the battery plant. And I think it reduces 4 or 5 months worth of burn-in time trying to get to your actual production yields for batteries. And it takes basically like the SMEs that are like best in the world for doing battery plant production, to all their knowledge accessible to every technician. So whenever someone's like, hey, my yield's at 70% and I need to get up to like 90%, these are the expert methods that they use to get there. And so then you get that training happens a lot faster. Next one is GearPal. GearPal is the one that was the 70% reduction. So every time a machine goes down the line, typically it was taking 3 or 4 hours for it to get back up, and that can cost millions of dollars of downtime. But mostly it's because you have to go hunt for the machine codes to reactivate and recalibrate. And so what GearPal does is allows you to load in the machine code, get down to the page on the manual that actually shows a restart sequence, and then reduce that downtime from 3 hours to 3.5 minutes or so. And so then the other bot is Material GPT. So this is materials formulation. So all of the different methods and formulas for generating like new paint or like new alloys and that kind of stuff can be loaded in. And then you can ask open-ended experimental questions about what could be new formulations for future paints, vehicles, finishes, that kind of thing for new minor model year changes or new major models. So what will happen here is these bots will then come together in a unified platform that we call Toyota GPT. But Toyota GPT is kind of like a very simple name for a complex platform. It connects foundation models that we have approved in our environment, plus these custom bots, and allows all of our team members to mix and remix based on like the permissions and access for their work. So you can experiment inside of an OpenAI model, send that to a Claude Sonnet model if you want to, and then drop it into CATIA bot if you're working on R&D, and combine that with the custom data that you need from that bot to actually have your output. And by putting that into a unified platform, we're actually making it so that people don't have to do so much screen switching. And then also helping that data can then turn into a new agents in the future when users, instead of coming to us for like custom dev, they can actually say, here's my workflow between these bots. Can we make that a specific expression? And I think right now our spin-up time is like 2.5 weeks for each one of these bots. So the idea is to like not have to keep treating them as bespoke technology implementations that have to get approval every single time, but say this platform is approved, use it as you need to, and then we're going to keep adding to it. So I'll turn it over to Ravi to walk through our architecture.
Cool, yeah, thanks so much. So I think one more point I wanted to add here is, you see a lot of Toyota cars in the US. The colors that we get with colors, like you see all of the colors, these are all inbuilt custom made. So we approximately take 2 years just to create a new color. Meaning we're gonna do a lot of research, we put it in before the sunlight, and we put all the UV rays. I mean, all the testing will be taken care of with the paint, and then we select the color. Yes, this is the right color that we need to go to for the cars. So for this team, we have done. I closely work with the team. So we have done a lot of the generative AI models, especially helped that reduce that 2 years of time, and how we can able to use our existing knowledge that we already had and bring up with the new knowledge as well. So I'm going to talk about some of the architectures. So this battery brain architecture is kind of, if you see, this is a RAG. So we're going to use, this is a very high level RAG that we have initially started with. Even then in the last year conference, we have presented this one. The reason why we have showing this one this year is, this is where we started our journey with a RAG. A lot of use cases that we got to enterprise AI team is all build me a RAG system, build me a RAG system. Basically, I want to chat with my documents. In the same way, again, you see the same architecture for, again, Gearpal. You also see the same architecture for battery brain. You also see the same architecture for material GPT. You also see the same architecture for Katia bot. So it's the same architecture. So what we have done from enterprise AI team is we came up with a kind of a platform. So how you have ChatGPT, we also have something called Toyota GPT internally, where we created a backend orchestration layer, which Stephen was mentioning earlier, that we used LangGraph to create this architecture. But before we do that, yeah, of course we should do that. So yeah, I work with Harrison team every single day. So yeah, we use LangGraph to do, and we also use Crew AI as well. So we also use LangGraph to build this particular architecture. And we don't need to, again, if any team comes to our team and said, okay, I want to build a bot. No, we just need to configure a configuration file. That's it. We'll be up and running in production. So to spin up a bot in production in any enterprise, it's going to take minimum 6 months. You know it. So what we have done is our team really helped, like our enterprise team, cybersecurity, all the architecture team really helped us to go over full speed that, okay, we created a platform that really enables any single bot to be in production in a week or 2 max. So that's the target. So once we see that, okay, we are, for every single project before, initially when we started this one, we used to hire 6 resources for every single project, and then we're going to work it. It's going to be a lot of cost. So that is where we came up with this architecture, and then we built this one. So the main thing the problem that we have seen is, I'm going to go a little bit technical here. So the main thing that we have, the problem that we have seen is ingestion. So it's all documents. We have Japanese document, we have Spanish documents, we also have diagrams, we also have tables, inside tables, inside tables, inside images, inside tables. So yeah, you name it, we have it. We also have a lot of different kinds of structures, PDFs, docs, MD files, every single file that you name it in the format, we already have all of those. So we don't have any of the existing tools out there in the market that solves all of this kind of problem. You got it. Yeah. So the ingestion standpoint. So what we've done is we took the embeddings, we uploaded the data, and we did a lot of conversion. We have a lot of different languages. We converted into English. We used generative AI models for this one, and we also have some translations, which is coming from Azure. So the next is extraction. We have taken all the extraction, which means we have used in the extraction itself. There is a lot of almost, I think I would say, we have because if you don't extract proper data, you don't get anything from the retrieval. First of all, you need to extract information that is there in the sheet or like the PDF documents. That is where we see, okay, the extraction is very, very important. So we spent a lot of time in extraction itself, making sure that not even a single page in any single content is not even missed. You name the table, you name the image, you name every single thing. We have built a solid ingestion pipeline that extracts every single information from the documents. And then we vectorized it. So I'm going to talk about the how we have worked on, how we solve this particular embeddings problems and other stuff. Yeah, so the best thing and the bulletproof is, if you want to see what kind of embeddings that you want, is just go ahead to Hugging Face and see what are the best embeddings model that is there in the market. So we saw at that time it is like text embedding 3 large. So we took that model. And then we didn't done any basically deep on this one, but we also created some of the fine-tuned embedding models, which we're going to talk about it. So yeah, so what we have done is for, especially for specific keywords like battery brain, which is we also have for material GPT, they have a lot of third acronyms, which language model doesn't even heard of it, not even once. So that data will not even present anywhere. So what we have done is we did a fine tuning on these embeddings, because when we did the fine tuning, the retrievals are really good. When the retrieval results that we are getting from the embeddings from the vector store is pretty good. So that's where we did fine tuning on some of the embedding models, not for all use cases, but only for a few use cases that really worked well. Next slide. So what we have done to the business is, okay, we asked if any business user wanted to build a chatbot, okay, you have any SharePoint? So we build a lot of connectors. We could build with SharePoint. And do you know how much time it's going to take to crack SharePoint? I'm not kidding. And also with cybersecurity in place in enterprise. So you can't get a read.all permission to all the SharePoint. You need to get only read dot selected for every single path, and then you need to get that. So like that, we have a lot of other tools. We have Confluence, we have, you name it, we have Jira, we have everything. So what we have done is we have created that particular framework where it enables even that security layer as well in place, and only extracted the key elements that are required for those respective use cases. So yeah, we build a data agnostic ingestion pipeline, and we also have a lot of OneNotes, we also have a lot of Word documents, PowerPoint, so everything we convert to PDFs. But I think we also, sometimes what we have done is Excels. In Excel, we have table, and then beside, they will add a picture, and they will basically take what is that? An arrow mark and point it to one specific column in the table. And we also need to get that meaning as well, because users are expecting that. So our ingestion pipeline is solid in such a way that we extract even the arrows that represents the meaning, we extract that. And even the images, we extract it. So we make sure that even the intent between these information is very useful. We extract it basically. So next slide. Okay, yeah, as I mentioned, we did translations to all different languages. So we have a lot of Japanese languages. So we converted that to English by default. Extraction. So what we have done is, in terms of extraction standpoint, we did a page level chunking when we are inserting inside the vector store. So we have Excel extractor. We have, I think this is an older one, but we have so many number of extractors that we extract from information from. So we also have CAD files. I'm not sure how many have heard of CAD files. So CAD files has a lot of information that is there inside, diagrams. If you see his CAD file, it is like, oh, is this blurry? No. When you zoom in, you will see the real picture of what's happening in the CAD file. So you should also get the meaning of how you create how you have the meanings in the diagrams as well. So one CAD diagram is you can get a lot of content out from the one CAD diagram. So they work on one CAD diagram just like they work on 6 months to build an entire architecture of the car ecosystem. Next slide. Okay, on the vector standpoint, so what database that we have selected? So in Toyota, to get anyone inside the Toyota, so it's going to take a lot of time to do an MSA. So that's where whatever we have on the time with us, we have taken that, which is we have Pinecone open search as well as Neo4j. So we have taken some of them, and then we are working on, we have built some use cases, ingested some use cases into some of the vector store, and then ingested some into Pinecone as well. So just making sure that which is performing well. We need to, because we can't just rely on one single vector store and then dump all our database, because when I say data, I'm talking in terabytes. So we have so many number of documents, not just gigabytes as well. It's all terabytes. Every single use case that you saw earlier is all terabytes. So like that, we are almost doing 50 use cases maybe? Mm-hmm. Yeah. So In terms of the images also, we converted to a base 64. We also we sent to best models in the world, which is like, we also have best models that we have sent in. We extracted all the information, and we extracted the mappings, we extracted every single information that we have done, that's there in the pages. Next slide. Okay, index. So when we are indexing, what we have seen is, okay, we have a SharePoint root folder, just an example, and then we have divided that into different files. So first attempt, what we've done is, we did an index on file, but we have a slow BFS with broad tree, and the next second attempt is like, it's less accurate because you have subdirectories as well, but we have a fast DFS. The third attempt is like balance accuracy between the file as well as subdirectories. And the fourth attempt is where we have done a research on how we can able to do a K-means, unsupervised learning, and then try to divide those documents into different buckets, and how we can able to ingest the buckets. Because when a user asks a question, I can able to know, okay, what bucket is they're talking about. I can able to suggest them. And I think before we have done all of this, but I think right now today also we are doing a lot of more research into each of these individuals as well, because now for us building a RAG bot is agentic RAG bot is very easy for us. But tomorrow we are also working on each individual aspect of, because now we are seeing problems that are coming out from these respective architectures that we're building. Meaning one user will have in a mind that, okay, I want this information. He has that inside his mind, but it's not in the document. What shall we do? So he's saying the retrieval is coming wrong. Come on, no. The wordings that basically the requirement that he is transforming into the programming that is not yet transformed. Meaning what I mean to say is, those keywords are very important. Whatever that he's thinking in the mind, those needs to be converted as a prompt engineering. So what we have done is we spent a lot of time with the business users. We extracted the information of, okay, what exactly are you looking for? Because when we built a bot and then give it to the users, they're saying, it's pretty good, I like it, but 20% of the results are coming wrong. No, we need to tune their mind in such a way that, okay, this is how the algorithm works. You need to think of it. And then what we have done is we have given something called thumbs up, thumbs down. You know it, right? So if they click on thumbs down, tell us why it's thumbs down. Okay, you did not like the response, or what is it? So we have implemented a feedback and loop mechanism where if something is wrong, so those are all, we're trying to collect all of it to a different repository, and then we are trying to we have a good amazing engineers trying to see, okay, where exactly is the problem? Is it in a retrieval, or is it in a ingestion itself? So when we saw all of these problems, if we change any of these respective bots, it's going to affect all of these, which means it will improve all the other existing bots as well. So that's one thing which we have found. And we did an evaluation for all of this. So I mean, in terms of evaluation standpoint, we have taken a golden data set from users, meaning give us like 10, 20 questions. We're gonna deploy that inside our code base. Whenever we change any of our code base, these 20 questions runs, and then see how the evals are working fine. So if there is any change in the all the RAGAS metrics. Next slide. So yeah, this is how we give the feedback. So you give thumbs up, and we take the screenshot automatically and then explain the scenarios. Some of the evaluation technique that we use that really worked is also, you can look at this one thing really worked, but now we have changed a lot. We have implemented Fusion. We also implemented re-rankers in place. But some of them, I think we have done almost a lot of good job in terms of evaluating. So, but when we change anything, this is going to affect all other use cases, meaning they're going to get better results. So whatever we are building, we had make sure that we have built a solid configuration. Everything we build, it should be configurable. So, next slide. Similarity metrics. Yeah, see, these are some of the similarity metrics. I want to skip those because I have a lot of other slides. You can read one of this good paper to some of similarity metrics that we have used is, all of this we have used malady-based distance, dot metrics, Hamming distance, Jaccard similarity, and some of them work really well. So yeah, some of the learnings that we have done, I mean, in terms of the unstructured data is very difficult, but we have solved it in Toyota. So this is how the Toyota GPT looks today. And you see the left-hand side, those are all agents. So we built agents for manufacturing, we built agents for supply chain, we have built agents for R&D, we built agents for different teams. And if anyone wanted to have a conversation with these agents, they'll just click on access, and we approve it, and they can just chat with the agent. And we had make sure that only people who are having the access to these respective data only can able to access it. Meaning the SharePoint, if they don't have access to SharePoint, they can't access it because you're not the member of the team. So some of the multi-agent architectures that we have used in this framework that we have implemented is we also have networking, we have supervisor, we have tool calling, we also have hierarchical, we also have custom-based approaches. So we just need to configure, as I mentioned earlier, in the configuration file, we just need to say, okay, configure, deal done. So in terms of memory standpoint, right now we have a short-term memory and we also have checkpointer. We also have a long-term memory. We also have, some of these memory types that we have went with semantic. We also tried with we have tried all of this, and we make sure that, okay, this is configurable. Tomorrow, let's say if there's a problem that came in, how can I able to tweak in, okay, now, no, I just want long-term memory, not short-term memory. Just changing the configuration, that will work. So initially we went with, the router-based approach, which means before MCPs came in, we have like 3 or 4 databases. We wanted to call any of these databases. The LLM is to have trouble knowing the information, because whenever you ask any information about paint, it's gonna call corrosion. But we don't want corrosion. We want the documents from paint. So how do we solve this? So the tool calling, which LangGraph implemented, is really pretty good, because whenever you found it couldn't able to find the documents, it will automatically in parallel hit the other tool and make sure did you find any documents, and it's gonna pull those documents. If you find this, and just send it back to the user response. This is a good retrieval strategy that we also used, which worked really well. So we used a KNN, vector similarity, and we also did text matching. And we did a 70-30 rule. We also did an 80-20 rule. We also did a 90-10, and see how it's performing. So yeah, all of that we have done. And then we also work really closely with some of the Pinecone experts who really write on algorithms. We also work with some of the open search experts who really wrote those respective codes. So we went there and we explained them the problem. They're gonna solve us. So every single week we will have frequent calls, and then anything new comes in, we will make sure that we are on the top. So some of the loaders, chunking, routers, vector databases, and some of the LangGraph memory management that we have used, and some of the agentic frameworks that we have used. So this is kind of a deep on what all things that we have built into this platform. With that, I will take some questions. Sorry, your question is not loud.
Oh.
Yeah, okay.
So I'm saying the biggest differentiator that I'm seeing with Toyota in manufacturing is you're building your own agent infrastructure.
Mm-hmm.
Yes.
And it's really the only way to enable all the analytics you can collect and the feedback system into your production lines.
Yeah, because for a couple of reasons. Security is one of the major reason, and we also need to make sure that confidentiality between the data is also important between the teams as well. So that's the reason why we went in this approach. But we also work with a lot of other vendors, and making sure that we also put in a lot of efforts to make sure that, okay, it's like a build versus buy, right? So
Yep.
Add some drawing.
Yeah, I was gonna say that. So we actually do have a strategy we call build, configure, buy. And a lot of it is based on if there isn't a solution that solves Toyota's specific needs, and Toyota's needs are dictated by the use case, but also by the data type. So I would say data in Toyota has at least three copies everywhere. So that's like if it's a vehicle or a customer or something else, there's at least 3 examples, because you have mainframe systems, you have what is essentially like 2000 to like 2015 systems, and then everything else, and all of it was in some version of digital transformation before Generative AI showed up. And everyone wanted to put Generative AI on top of all of them, and so you can see the mess that could create if you're trying to force it all into one specific solution. And when we started looking at all of this, everything was very, very nascent, and we were building with AWS and Preview for a bunch of tools, but no one had a SaaS platform that had solved all of these pieces. So we're like, okay, if we build something custom, we'll understand our own requirements and everything Ravi laid out about what we need to do to actually get to certain outputs. And if there are some platforms that show up in the future, we can configure them. If we can't configure them, then we'll continue with our solutions in hybrid, and then if someone does release like the one orchestrator to rule them all, we then buy that and load them all in, test it against our custom software. So the idea is basically continue to upgrade in place, accept tech debt as like a standard, and then build against it versus trying to optimize before you get started. Which is a little bit difficult because we're a manufacturing company. A lot of people come from like Six Sigma backgrounds and waterfall. But we just keep having those conversations and educating and trying to do very quick POCs to get them past like the initial requirements so they can start working with actual outputs.
Unfortunately, we're out of time. Let's give a round of applause to our speakers. Thank you.